will talk about the science third chapter, that means structure of matter. And this is part 1. So let's see. The objects have a mass and occupy a space are called matter. The objects have a mass and occupy a space are called matter. And matter can be classified into two types, as mixtures and as pure substances. The objects have mass and occupy a space are called matter, and matter can be classified into two, as pure substances and mixtures. And again, pure substances can classify into two, as elements and compounds. And mixtures also can be classified into two, as homogeneous mixtures and heterogeneous mixtures. In pure substances, examples for elements are iron, oxygen, copper, and nitrogen. Examples for compounds are water, carbon dioxide. In mixtures, examples for homogeneous mixtures are salt solution and sugar solution. Heterogeneous mixtures, lime plus water, rice plus sand. The things in our environment can be classified into two main categories, as matter and energy. The things in environment can be classified into two categories, as matter and energy. The objects occupy a space and have a mass are called matter. Atoms are the building units of matter. Atoms are the building units of matter. The atom is composed of subatomic particles. Atom is composed of subatomic particles. Among them, protons, electrons, and neutrons are the main subatomic particles. The atom is composed of subatomic particles, and among them, protons, electrons, and neutrons are the main subatomic particles of atoms. However, the protons and electrons are oppositely charged, and therefore the atom is electrically neutral. So that means protons are positively charged and electrons are negatively charged. So the atom is electrically neutral. According to the nuclear model put forward by Ernest Rutherford, there is a very small area called nucleus at the center of the atom. According to the nuclear model put forward by Ernest Rutherford, there is a very small area called nucleus at the center of the atom. The electron is a negatively charged particle. Protons has a positive charge, and while neutrons have no charge. Neutrons no charge, protons positive, and electrons negative. Our first subtopic is the planetary model of the atom. The planetary model of the atom was introduced by Ernest Rutherford. We discussed this. Electrons move around the nucleus in which the positive charge of the atom is concentrated. Niels Bohr, who further elaborated the Rutherford's model, stated that the electrons move in definite parts or shells around the positively charged nucleus. Niels Bohr, who further elaborated the Rutherford's model, stated that the electrons move in definite parts or shells around the positively charged nucleus. The shells or the parts around the positively charged nucleus are assigned either numbers 1, 2, 3, 4 or letters K, L, M, N, respectively, starting from the nearest to the nucleus. The shells in which the electrons revolve around the nucleus are assigned either numbers of 1, 2, 3, 4 or letters K, L, M, N. This is a picture of Ernest Rutherford, father of planetary model. The shells are also known as energy levels. Each energy level has a specific energy. The shells or different parts revolving around the nucleus are also known as energy levels. Shells can be also called as energy levels. Each energy level has a specific energy. In an atom, there is a maximum number of electrons in any energy level gives the total number of electrons in the first 4 energy levels nearest to the nucleus. There is a specified energy for each energy level. In an atom, there is a maximum number of electrons in any energy level gives the total number of electrons in the first 4 energy levels nearest to the nucleus. So in first energy level, there are 2 electrons. So here 2 electrons. In second energy level, there are 8 electrons. 8 electrons. In third energy level, there are 18. So there are 18 in third. And in fourth energy level, there are 32. Okay, let's discuss atomic number. The atomic number is the number of protons in an atom of the element. The atomic number is the number of protons in an atom. There are 11 protons in the nucleus of a sodium atom. So the atomic number of sodium is 11. So it implies that the atomic number of an element is equal to the number of electrons in an atom of that element. The atomic number is the number of protons in an atom. So if sodium atom has 11 protons, atomic number is also 11. Oxygen 8 protons, atomic number is also 8. And so it implies that the atomic number of an element is equal to the number of electrons in an atom of that element. Number of protons equal number of electrons. So if number of protons equal the atomic number, the number of electrons also equal to the atomic number, mass number. The mass of protons and neutrons is nearly equal. Approximately, the mass of an electron is 1 divided by 1840 the mass of a proton. So, if we get it like this, protons 1 and neutrons also 1, electrons 1 over 1840. So electron is the lightest subatomic particle among these three. The mass of an atom depends only on the mass of protons and neutrons, because electrons is lighter than these two. The sum of the number of protons and neutrons in the nucleus of an atom is called the mass number. Sum of protons and neutrons equal mass number. Atomic number is number of protons. Atomic number, number of protons. Mass number, sum of protons and neutrons in that atom. Symbol A signifies the mass number of an element, and the symbol Z signifies the atomic number of an element. Atomic number of sodium is 11. Hence, a sodium atom contains 11 protons. If it contains 12 neutrons, the mass number of the sodium atom is 11 plus 12, 23. It's like this. Sodium, protons, number of protons in sodium is 11 and number of neutrons is 12. So what is the atomic number first? Atomic number is number of protons and it's 11. Mass number, it's sum of number of protons and number of neutrons. So 11 plus 12 equal 23. Mass number is 11 and atomic number is 23. And there is a way to represent this atomic number and mass number. And this is the standard way. Here the and this A symbolize mass number, and this Z letter symbolize atomic number. When it comes to chlorine, chlorine is the element 23 is mass number because number of protons is 11 and number of neutrons is 12. Sum of 11 and 12 is 23. This is atomic number. Let's move to electronic configuration, representing how electrons are filled in the respective energy levels from the ones nearest to the nucleus of an atom and outwards is called electronic configuration. Representing how electrons are filled in respective energy levels is called electronic configuration simply. The atomic number of sodium is 11. Therefore, a sodium atom has 11 protons and 11 electrons. Those 11 electrons in the sodium atom are distributed as 2 electrons in the first energy level, 8 electrons in the second energy level, and 1 electron in the third energy level. So it's like this. Sodium has 11 electrons, and in first there are 2 electrons, and in second there are 8, and in third 2, 8, 10 there is 1 electron in third energy level. Guys, in this lesson we only need first 20 elements of the periodic table. So let's see the electronic configuration of hydrogen. Hydrogen is the first element in periodic table. So the number of protons in hydrogen is 1. So the atomic number is also 1. And in the first energy level, it has 1 electron. Helium is the second in periodic table and it has 2 protons. So the atomic number is 2. And the number of electrons in first energy level is 2. Lithium is third and atomic number is 3. So number of energy levels in first energy level is 2 and lithium is the third element in periodic table and its atomic number also is 3. There are 2 electrons in first energy level and there is a 1 electron in second energy level. Beryllium atomic number is 4, 2, 2. Boron atomic number is 5, 2, 3. Carbon atomic number is 6, 2, 4. Nitrogen atomic number is 7, 2, 5. Oxygen 8, 2, 6. Fluorine 9, 2, 7. Neon 10, 2, 8. Sodium 11, 2, 8, 1. Like that. When an energy level of an atom of an element is the last energy level bearing electrons, the maximum number of electrons it can accommodate is 8. When an energy level of an atom of an element is the last energy level bearing electrons, the maximum number of electrons it can accommodate is 8. So here it can the maximum number of electrons it can accommodate is 8. So here the maximum number of electrons it can accommodate is 8. Okay guys, let's discuss about modern periodic table. Like I said, the first element in periodic table is hydrogen, second helium, third lithium, beryllium, and fifth boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. In this lesson, we need only first 20 elements. The first 20 elements. So it's only this. First 20 elements. from hydrogen to calcium. Hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. You need to memorize these 20 elements in periodic table, and it's easy. No need to worry. At present, more than 115 elements have been discovered. Studying their properties individually is a very tedious task. Tedious means hard. Scientists in various parts of the world collect information about elements and their compounds continuously. At present, there are 115 elements discovered. Studying their properties individually is a very hard task. So, scientists in various parts of the world collect information about elements and their compounds continuously. A periodic table for classifying elements was first introduced by Dmitry Mendeleev, a Russian scientist. The periodic table for classifying elements was first introduced by Dmitry Mendeleev, a Russian scientist. The periodic law states that the properties of elements are periodic functions of their atomic number. This means that when the elements are arranged in the ascending order of their atomic numbers, elements with the similar properties recur at regular intervals of elements. First element is hydrogen. Second one helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. So let's see the atomic numbers of those elements. Atomic number of hydrogen is 1, helium is 2, this is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19, 20. So by this we can conclude that the number of protons in hydrogen and number of electrons in hydrogen is 1. Here 2, 3, 4, 5, 6 like that. And this is first group, this is second, third, fourth, fifth, sixth, seventh, and this is eighth group. The horizontal ones are groups and the vertical ones are periods. This is fourth period, third period, second period, first period. So what is the element in group number 5, period 3? Yeah, phosphorus. What is the element in group number 8, period 2? Neon. So let's move to other parts. Dividing elements into periods. The period to which an element belongs is decided by the number of energy levels carrying electrons in an atom of that element. The period to which an element belongs is decided by the number of energy levels. So period 1, only the first energy levels carries electrons. That means hydrogen and helium is in period number 1. Period 2, only the first and second energy levels carry electrons. First and second, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Those are in second period. In third period, only the first, second, and third energy levels carry electrons. That means sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. These elements are in period 3. At last, in period 4, only the first, second, third and fourth energy levels carry electrons. Potassium and calcium. This potassium is represented by the symbol K. No? The meaning of this symbol K is, it's a Greek name, kalium, dividing elements into groups. The properties of an element depends on the number of electrons present in its outermost energy level. These are known as valence electrons. As per the above table, it is seen that the properties of lithium, which has only one valence electron, is similar to that of sodium. Sodium too, which has only one valence electron, it is seen that the properties of any element in the upper horizontal row is similar to those of the element below it. The group to which an element belongs is decided by the number of electrons in its outermost energy level. The group to which an element belongs is decided by the number of electrons in outermost energy level. Number of electrons in the outer energy level, group to which element belongs. Elements with one electron in the outer energy level. Elements with one electron in the outer energy level: hydrogen, lithium, sodium and potassium. Elements with two electrons in the outer energy level, group 2, and this is group 1. The elements belong to group 1 is hydrogen, lithium, sodium and potassium. The elements belong to group number 2 are beryllium, magnesium and calcium. The elements belong to group number 3 are boron and aluminium. The elements belong to group number 4 are carbon and silicon. Group number 4, carbon and silicon. We wrote this. Group number 5, nitrogen, phosphorus. Group number 6, oxygen, sulfur. Group number 7, fluorine, chlorine. Group number 8, helium, neon and argon. The gases helium, neon and argon are noble gases. They are noble gases. Okay guys, let's discuss about isotopes. The atoms with different mass numbers in the same element are known as isotopes of that element. The atoms with different mass numbers in the same element are known as isotopes of that element. Hydrogen has 3 isotopes and they are protium, deuterium and tritium. Hydrogen has 3 isotopes and they are protium, deuterium and tritium. Chlorine has 2 isotopes and they are mentioned in this standard Chauvin method. So normal chlorine is this. This is the isotope. If we get the chlorine element in our Earth, our planet, if we get the amount of chlorine in our planet, 75% of them are normal ones and 25% of them are isotopes of chlorine. The normal one has 17 protons and 18 neutrons. The isotope has 17 protons and 20 neutrons. Patterns seen in the periodic table. In the periodic table, it can be seen that the physical and chemical properties of the elements change according to a systematic pattern across a period from left to right and from top to bottom of a group. To study those patterns, let's consider the following properties of the elements. First, ionization energy and electronegativity. Let's see. First, let's discuss about first ionization energy. In accordance with the nuclear model of the atom, its electrons orbit the nucleus, revolve around nucleus. The negatively charged electrons are attracted by the positively charged nucleus. So to remove an electron from an atom, energy must be supplied to overcome that attraction. The negatively charged electrons are attracted by positively charged nucleus. So to remove an electron, we need to apply an energy to overcome that attraction. When an electron is removed from an atom, it becomes a positive ion. This is the graph of first ionization energy. Hydrogen, helium, and goes down lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, and again goes down. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, and again goes down. Potassium, calcium. The elements having the largest first ionization energy is hydrogen and neon. Helium and neon. Element helium and neon. Lowest ones are lithium and sodium, potassium. We can see that this is first period, hydrogen and helium, and it drops, and again in second period, and it drops third period, and this is fourth period. The first ionization energy of an element is the minimum energy that should be supplied to an atom in the gaseous state to remove an electron to form a unipositive gaseous ion. The first ionization energy of an element is the minimum energy that should be supplied to an atom in the gaseous state to remove an electron to form a unipositive gaseous ion. Don't worry, we will discuss this in grade 11 and grade 10 chapter 7 also. This energy is a comparatively small value for an atom. Therefore, this value is given for 6.022 into 10 to the power 23 atoms or a mole of atoms. Accordingly, the first ionization energy of sodium is 495 kilojoule moles. In a period, the group 1 elements have the minimum first ionization energy, and also in every period, group 8 elements have the maximum ionization energy. From left to right in a period, the first ionization energy varies in a regular manner. This is the first ionization energy graph. I discussed this. It can be concluded that from top to bottom of a group, the ionization energy decreases. Descending a group, the number of energy levels in an atom increases. Therefore, the attraction exerted by the nucleus on the electrons in the outer energy level becomes less, making the removal of electrons easy. Electronegativity. Electronegativity means the ability of an atom of an element to attract the electrons of a bond towards itself when it is bonded to another element. Electronegativity means the ability of an atom of an element to attract the electrons of a bond towards itself when it is bonded to an atom of another element. The attraction of an atom of higher electronegativity towards electrons is greater than that of lower electronegativity. More about electronegativity will be discussed under the unit on chemical bonds. This lesson is chapter 7. We will discuss more about electronegativity in chapter 7. As per the Pauling scale, fluorine is considered the element of highest electronegativity, there are several scales to quantify the electronegativity, of which Pauling scale has been adapted here. The scale to measure electronegativity is Pauling scale. There are some different scales also, but here Pauling scale has been adapted. Study the electronegativity values and the graph that illustrates the variation of electronegativity values well. It can be seen that the electronegativity increases from left to right across the period. It is also seen that down a group, electronegativity decreases. This is the electronegativity graph. So you can see fluorine is the highest electronegativity and chlorine is secondary highest, and the lowest ones are lithium, sodium, potassium.